Hello guys, in this session I am going to explain about merge sort and its implementation in Python. Basically it is based on the concept of divide and conquer strategy, which you must have seen in data structure class, and where the objective is to divide a larger problem into small problems, and so that it is manageable and easily we can merge based on the sorting concept. So first phase is to keep on dividing till we get the only one element at the end, and after that we'll start merging one at a time, and partially whatever merge solution we will be getting, that would be sorted in itself. So partially sorted data will keep on getting in reverse order, and finally we'll get the whole data sorted. This is the basic idea. So what is there is whatever data is given to us, we'll divide that into two halves, and these two halves are further divided. Those four halves are further divided till we reach to the divided part of size 1, and then finally we, in reverse way, will keep on merging the blocks that we just divided. Okay, so the basic algorithm for merge sort would be like, we are given a list and its starting index and ending index in the form of L and R. So just like similar to binary search, here also we'll find the value of middle, which is M, and it is equivalent to L plus R by 2. So it will give some value. You can interpret this division, either it should be floor or something else, depending upon the language that you are going to use. So here after finding the M, what we are doing is we are applying the merge sort. This algorithm recursively is being called. So if we call this algorithm recursively, again it will find the value of M. So but in that case we are calling this value from not from LR but for L to M. That means as we have taken the value of M, so we'll divide this data into two parts, from starting index, like here starting index up to middle value, and then from next element from the middle value up to the last element. So these two parts we have created. Recursively it will again divide, keep on dividing, and this merge will be called after this this R is equal to 1. When R becomes equal to 1, like sometime will when this condition will fail, it will go to this merge part. Fine, we can see through some example. Like if we have this data 38, 27, like some data is there, and L value and R value that we talked of, L is 0, 1, 2, 3, 4, 5, 6, so R is 6. So that 0 plus 6 by 2 is calculated, and based on that this data is divided into two parts. Now again this particular part is called for division, and it divides into further two parts. Before completing this is again divided into two parts. Now we reach to element of single size, so merge function will be called there. After calling merge for these two, merge for this particular step which was left behind, it is again divided. After dividing it, it is merged. Now after merging it, we will merge these two elements, and finally we'll get this. After this we'll move to the second half, and this same process is repeated. So whenever we are merging in a way that the merged part is again sorted. Like in this case, these two elements were merged with the view in mind that finally data should be sorted. So that concept we keep on applying in the terms of merging, and we keep on dividing in forward direction. So in this way we have to implement, keeping in mind this particular concept. So how we'll implement this merge sort? We'll define a function merge and another function merge sort. So merge will combine the two fragments, and merge sort will follow the recursion stack and the process of division. So Suppose whenever we'll call this function, we'll call from merge sort. We are given this data in the array list, and we calculated the length of this array and call this merge sort function with this data 0 index n minus 1, that means the last index. So 0 to n minus 1 we have called this function. Now this r is passed to this r, 0 is passed to l, and n minus 1 is passed to r. So if l is less than r, that should be the condition, that l should be less than r. In that case we are finding the value of m, which is l plus r minus 1 by 2. This m value, after that we'll call this function for first half and second half, merge sort for r, l and m, and then merge sort for r from m plus 1 to r. Okay, so this is how we are applying the concept we have taken here. Like, we have to find out the middle value, we'll find merge sort, and then 2 times for first half and second half, and then we merge it. So here again the same process is applied. After we return from these 2 calls, we'll start merging. Okay, now we need to understand how we merge. So the basic idea of merging is, like, if we talk of these 2 blocks to merge, so we'll compare the first element of this and first element of this. So like 3 is smaller, so it is given into the final block, and 9 is larger, so it is given next to this. After that, if we talk of 27 and 10, so out of 27 and 10, 10 is smaller, so that will come first, and then 27 will go. Now if we talk of 38 and 82, 38 is smaller, so it is there next. After 38 we have 43, which is again lesser than 82, so we'll put 43, and then we'll put 82. So we can take any element from either of this block while merging, so we need to take care of which one is smaller and which one is larger, and according to that only we'll store this data in third array. Okay, so with this in mind, I am starting the explanation for this code. Merge array LMR. What is this L? L is this particular first index, M middle index, and R is the last index. So from first to middle, and from middle plus 1 to R, these are the 2 blocks that we need to merge. So we'll find that how many elements are there in the first block and how many elements should be there in the second block. So for this calculation we are using this formula, m minus 1, actually it is m, this particular L, so m minus L plus 1, and n2 is r minus n. So by this we'll find out that how many elements are currently in the 2 blocks given to us through merge function for merging. Okay, so now we'll create 2 empty arrays L and R for 0 values initially. The n1 elements replication operation we are applying here on 0 list, and n2 times on for R. So left and right part empty blocks we have created, empty list with 0 values initially. Now what we are doing for I in range 0 to n1, like for all elements for the first block, what we are doing, we are placing on this blank list all the elements from array which were given to us. Whatever is there in the array from the first index up till the last index of that particular block, we are putting onto the left part. Similarly, we are taking the array values of the corresponding block into the right part. Like this, what we are doing, these 2 blocks of the array we are placing in temporary memory area. So I, j and k are the variables which here stores the indexes of first subarray, and j will handle the indexes of second subarray or sublist, and k will handle index of merge subarray, because these indexes are required to track for placing the values at corresponding position. So what we are doing here is I less than n1 and j less than n2. Like whatever number of elements are in the first subarray or in the second subarray, if either of this exists completes, we can stop. So either we should be having we reach the limit of elements in the first subarray or in limit of elements in the second subarray. Till that point we have to take we have to first of all check whether the element in the left subarray is less than or equal to element in the right subarray at ith position in the left and jth position in the right. In that case, in the final array we have to place the all such elements from the left and increase the value of I. If it is not the case, we have to take the element from the right, okay, and increase the value of j. Finally, one element will found in the final array, so we'll increase the value of k. Now after completing this loop, we may have, like, this condition is not satisfied. In that case, either n1 is completed or n2 is completed. So some elements are there which needs not comparison, but they needs to be placed in the final array. So we'll check that while I is less than n1, if this is the case, I has not been increased to the extent that it becomes equal to n1. So all leftover elements are to be placed from left array into the final array and increase the value of I as well as value of k. Similarly, if some element is left over in the right part, in that case j would be less than n2. In that case, take all the right part value with the indexes 0, indexes represented by j, into the array from index k, which are already filled. After that it will take all the values. So leftover values would be taken by these two loops. So in this way the process of merging is implemented. So if we are putting this input, this is the output we are getting. So I hope you understood the logic of merge sort and how we are implementing in Python. If any question, you can ask through comments or email. Till then, thank you.